Mars, Ceres, Lutetia. The physics required to put Ceres into orbit around Mars was not particularly complex to derive. Of course, science is not engineering, the like of which would have to be utterly titanic in its capacity to achieve this feat. The coding of this algorithm took 6 weeks, although the gravity engine itself required something celestial to accomplish it. But the engineering of how to put Ceres into orbit around Mars is also remarkably simple. It's the economics of it that just seems challenging by 20th century standards. Orbit Gravity Sim21.exe is designed to demonstrate how to put Ceres into orbit around Mars. We do this by launching asteroids at great momentum, which then impact Ceres. This alters its orbit by slowing it down, and then it speeds up again due to the Sun's increased gravity because Ceres has now moved close to the Sun. Then it can catch up with Mars, if you get the angles right. Otherwise, it'll just keep going around the Sun like normal, so you've got to impact it with quite a few asteroids. Notice how the algorithm runs at various rates of calculation, which you can alter, speed up and slow down. But you need to program an AI to actually do this more accurately. The way I've done it here, when you start, it's just to demonstrate how to go about it and how it all works. The simulator OGS21 demonstrates specifically in scenario 5 how to place the much smaller asteroid Lutetia into orbit around Mars by impacting it with 55 very small asteroids, each weighing 5,000 exakilograms. Now Ceres is roughly 1,000 times more massive than Lutetia, so it's up to you to adjust the parameters in OGS21 and then place Ceres into a similar orbit to the one I show in scenario 5 with Lutetia. The AI in this algorithm allows the user to experiment with orbital dynamics precisely. Alternatively, you can manipulate the orbits dynamically in real time in order to first get familiar with the launch parameters and their orbital evolutionary dynamics. The advantage of using the AI is that it will then give the exact same repeatable result each time. But it does require more skill to calculate, and thus far less energy for the launcher in reality. If you look at how I set up scenario 5, you will see 4 color-coded phases in sequence, as each event is triggered at a particular iteration, so the event is unticked. The first phase launches a series of smaller asteroids at your selected target and give an angle. This will change its orbital velocity and put it on a course towards Mars. The second trigger will speed up the orbital dynamic at a particular iteration, and the third trigger slows it down again to optimize efficiency. The fourth trigger then fires a salvo of identical asteroids to park your new moon in orbit around Mars. You can let me know in the video comments when you guess humanity will actually accomplish such a feat. However, putting Ceres into orbit around Mars consists of a matter of both astrophysics and planetology. So philosophically, the reason why we want to give the planet Mars a moon called Ceres is that this will energize the planet core, planet core, planet core, planet core. By melting the rock and generating magma tides, this new abundant heat will then push Mars's oceans towards the surface into liquid oceans. This heat will also sublimate dry ice and bring about a thicker atmosphere of CO2, ripe for phytoplankton to harvest and generate an oxygen-rich atmosphere. Putting Ceres into orbit around Mars will bring Mars to life. Putting Ceres into orbit around Mars will bring Mars to life. Putting Ceres into orbit around Mars will bring Mars to life. Putting Ceres into orbit around Mars will bring Mars to life. However, it's not only the AI launch sequence that you need to adjust. You likely need to tweak the orbit of Mars in relation to the position of your asteroid. This variable here is in radians multiplied by 1,000. You also might find that because everything from OGS21 onwards processes as close to the core as I can get it, in the future this algorithm might run too fast. So you can slow it down by adding large rogues into the matrix. If you look to the right with the focus on Jupiter, you can see how it toys with the rogue moons joyfully. Now, if you add rogues to the total number, then they become non-effective satellites in Saturn's rings. These extras do not affect the gravity engine, but they are affected by the gravity engine. So there's just two ways to slow it down, adding extra rogues. You can also play with the parameters in the top left to just see how big or small you want the rogues to be. But you can hover over stuff. The tooltip texts are active as usual, so that should give you most of the help you need.